Okay, let's look at question number 4. An object is moving in a straight line. Its acceleration, a meters per second square, is given by a equals 60 plus 1, where t is the time in seconds after passing through O. The initial velocity of the object is 2 meters per second. Find an expression for the velocity of the object at time t. Okay, again, I want you to, let's go first back to the textbook. So if you look in the textbook, this will be at integration. Okay, and I'm going to show you this example. Now, I just want you to, if you can still recall this, say it's distance, then velocity, then acceleration. Now, if you're going to this side, so I differentiate and I differentiate again. But if I come back, can you remember? I integrate, and if I go back, I integrate again. Okay. So just keep this in mind. But this is a very nice example. I think it's going to be helping you a lot. So you will find this on page 353 in the mathematics textbook. Y equals mx plus c to success AS-Level. Okay. A ball thrown vertical upwards from point O. At time t seconds, its velocity was v meters per second and is acceleration. So they are also giving you the acceleration, just like that one. Now, express this information in the form of a differential equation. So basically, I'm just putting a equals -10. And now I integrate. And as soon as I integrate, I'm finding the velocity. And don't forget, if you integrate, to always add c. Okay, now I must get that value of c. So the initial velocity, now initial means the beginning. That means when t is 0. Okay, was 12. So if I go, as I said, the initial velocity was 12, but then the value of t was 0. And that helps me to find the value of c. And now I can put it in because I didn't have it there. I was looking for it. Now I have, that is the formula for the velocity. And now they say, find the expression for the height of the stone above 0 after t seconds. Now again, that is height. I will integrate. And I integrate again to get the distance formula. But don't forget again your C2. But then, as soon as the time is 0, the distance is 0. Okay, so if there's no time, it didn't move. So I put 0, 0, and actually to get the value of c, and that's then 0. And there is my distance formula. And then I can work with it. Okay, and so I think up to there, it's going to be helpful enough. Initial, remember that, initial when time is 0. Okay, let's go back to the question paper. Okay, I'm just going to make it bigger. And I think that was a very nice, it's a very straightforward example. So I'm reading again and I underline a few things. An object is moving in a straight line. Its acceleration there is given, and there is the formula, where t in time is after par. The initial, that when t, the beginning, velocity is 2. Now, find an expression for the velocity of the object. Now, don't forget, start with the formula. Let's take my blue pen again. Okay, so the formula for acceleration, there it is, plus 1. And now I'm going to get my velocity. So I'm going to integrate, and 6t plus 1. And I'm just integrating. And as soon as I integrate, it's the velocity. So as I said to you, and don't forget, now I don't want to write it here because then you think you can write anything. So, but if you want, it's not a problem. You can maybe just to help yourself, if you really feel, you can say is. But I think this is very easy, and I'm coming back, so I'm going to integrate. Okay, so basically, I'm just going to integrate now, and I'm going to get 6. It's going to be t2 over 2 plus t, and I call it c1. Let's just get it c1 first. And now I'm going to say, if I simplify this, I can get it's 3t squared plus t plus c1. That is my formula. Now, initial velocity, I can say initial velocity when v is equal to 2. Then, initial means the beginning. There's no time, so t is 0. So I substitute. So if I'm going to, I put the 2 in, that's the initial velocity. I put the 0 in for time. Call that C1. So I get that this is 0, 0. So therefore, C1 is equal to 2. So actually you can just say, and then therefore, velocity equals 3t squared plus t plus 2. And again, if you come to the questions, I think you will just show that you're going to integrate by doing that. And then to come to that formula, after you, to get the integrated formula, there you did, and then to get your final formula there, or the value of c. Okay, because find the expression for the velocity. Now how far? So how far is going to s? So I must integrate again. So I'm just going up, up, up. How far is the object from O after 3 seconds? So I'm starting again to get my distance. I'm going to integrate again my velocity. And I'm integrating to t. Okay, so, and now I do that, what I wrote. So remember, it's 3, 2, I add 1, so 3, and I divide by that answer. Okay, so, and then it's t2 over 2, and there comes the t. And don't forget your c, and now let's call it 2 because that was c1. Okay, now I'm just going to rewrite it. It's not necessary that you do it. You can do it actually from the start, correct? But as I said in the videos, I'm concentrating to don't leave out steps so that students can follow. Okay. Now, when the distance is 0, the time is also 0. So if I put in 0 and I put in 0, 3, and I put in a half 0 and I put 2, 0, I'm just showing you C2. So therefore C2 is 0. So actually my formula for distance is just going to be t to the power of 3 plus a half t squared plus 2t because it's plus 0. Okay. And now I'm reading the question. How far is the object from O, the beginning, after 3 seconds? So that means now t is not 0, now t is 3. So I'm just going to substitute it. So I'm just putting my 3 in seconds. And then I'm getting 27. I'm getting there 4.5. I get 6. If I add up all, I get 37.5 meters. And that's how I do it. And again, it was 3 marks. I'm showing that you're going to integrate, getting the correct thing there. Then in your integrated formula, and then your final answer, getting a distance. I think that's where you'll get your marks. And that's how you do question number 4. Very, very straightforward. And I think the example in the textbook will definitely help you. Let's look at question number 5. Solve the equation, and I can see this is a trigonometric equation, and it's from 0 to 360. Okay, so let me take you first back to the textbook again. So let's see, where will we find that in the textbook? Okay. Okay, so I think this example will help you. It's on page 198. Just see, 198. Okay, and it's in chapter 4. So now we make use of identities to solve. So basically, what we're going to do is we're going to make it a quadratic equation. Okay, and I'll show you now how. So in this case, and actually this is also a good one. So basically we're just going to say, okay, so this is going to be 1, and I just bring the identities in. But as soon as I have it the quadratic equation, then all that I'm going to do, and I just want to check quickly something. I just want to put my sound off. Okay, so basically I'm just going to factorize it. I put the two equal, and then I'm taking it from there. I make my cast diagram and just check that both values fit in. And in this case, it fits in, or it's between. And if it's between, it's not including. But in that one, it's included. So in the domain. And that's how you do it. So if you cannot recall, you can just go back to your textbook, the AS-Level textbook 198, and you can just first work through a few examples there. Okay, but let's go back to the question. Okay. Okay, so let's see how we get that quadratic. So this one is actually very easy. So basically what we're just going to do, and I can maybe just write it first down for you, although our space is a bit limited because it's sometimes quite long. So we're going to make the denominators the same. We're going to multiply with the LCM cos theta. So basically, if I'm just multiplying there cos theta, multiply cos theta, multiply cos theta, multiply cos theta. And then, so as soon as I multiply cos theta over 1, cos theta over 1, but at the end, doesn't matter how you will get 2 equals 7 cos theta minus 3 cos square theta. And there you see the trinomial. Okay, so now I'm just arranging, and it's very good taking that one to the other side so that it's positive. So 3 cos square theta minus 7 cos theta plus 2, and that's equal to 0. Okay, and now it's a trinomial. I'm just going to factorize. So if I'm going to say this is in group A, like I always call it, so it's just going to be easy. So it's going to be 1 and 3, and it's going to be 2 and 1. Because I'm looking for 7, I must add. So it's 6 plus 1, and that will be 7. The signs will be the same, but both will be a negative. Don't forget that. Okay, so that's just to help me a little bit. And now I can write it down. So I'm going to have cos theta minus 2. And I'm going to have 3 cos theta. Let's just correct that. So 3 cos theta minus 1. And that's equal to 0. Okay. And now I'm going to put both equal to 0. So I'm going to have cos theta. And, okay, I can already say minus 2. And as I said, it's not necessary that you put all the steps in. I'm just doing it for the video's sake. So cos theta equals 2, or cos theta equals a third. Now, it's very important, and especially in AS-Level, that you know you have a little bit insight. So because if you know about cos theta, and you think about the graph, can you remember the cos theta graph? The graph is just going like, oh, my graph is now not looking good, but it doesn't matter. It's just like, I'm just showing you. But it's just going there from 1 to negative 1. But here stands 2. You follow? So it's not, it's rejected. Okay, so I can basically just reject that 1. I can just say, or not applicable, reject. Okay, and I basically just continue with this one. So now I make my cast diagram, and I write my, okay, let's just see, cast. Okay, remember, so where is it? Where is it? It's going to be, it's positive, and of course it's here. Can you see? And here. Okay. Now I'm going to press on my calculator. So I press Shift cos 1 divide 3. Just make sure your calculator is on degrees. Okay, and make it 2, because you must at the end to 1 decimal, so make it to 2 decimal places. So I get 70.53. And that one is also going to be 17.53. Try not to work in that space. So I could have moved it up, but for you, I think you will be able to fit everything in. Okay, so I reject that one. And now I'm just going to continue with this one. So the one angle will be from there to there. So I'm going to say, okay, so cos theta or theta equals 70, and I approximate it to 1 decimal place, or theta, and now I'm going to say, remember that's 360 minus, so 360 minus 70.53, and that will give me an answer to 1 decimal place, 289.5 degrees. So if you want, so I can just end up, let's just say, therefore, theta equals 70.5 degrees, or theta equals 289.5 degrees. Please remember, if you have more answers, they're going to penalize you. Okay, but I think in the exams, they will give a mark as soon as you come to the quadratic equation, and then if you come to the two answers, but no extra answers involved. Okay, very, very straightforward. So go to your textbook, at least make sure that you don't struggle with the basics going to the course diagram. Okay. Now, identities is quite challenging, and usually people struggle with this. And it's the more you do it, the more you're going to just see the patterns. But I want to take you to the textbook again, because if I can, I like to show you where you can do a little bit revision, or how you can in your brain just go back and think a little bit what. So it's always very important that you can connect things. Now, I just took this one. And the reason why I took this one, because I saw a tan. Now, what we usually do, as soon as we see tan, we take it to sin and cos. And that is what I showed you just there. So I just take it to sin and cos. And if it was now, not that we're going to use it in this, then I just make it, there's two fractions on top. So I make it 1, make the LCM, denominators the same, multiply the reciprocal, and we get the answer. So what I wanted to show you in this question, and you will find this on page 189 in the AS-Level textbook, it's on the trigonometry, is that take it to sin and cos. Okay. So if I go back to that question, let's just go back to the question, and now, and I make it a bit bigger. Okay. And now if I'm taking, as I said, to sin and cos. Now, I like usually to write it, but I think in this case, I'm just going to write the left-hand side. I can make it like that. And I'm just going to take out the left-hand side. Okay. So please don't work with both sides. I indicate this is the left-hand side. Now, taking it to sin and cos, so remember, it's, and I can again, it's sin square x over cos square x. If you go to the formula sheet, you will find this, but I think this is so basic, so that you will not make mistakes with this. Okay, and this is just sin square x over 1. I'll show you later in the question paper if we come again to the formula sheet where it could have helped you. Yes, I think I will go now to the formula sheet, but let's just make it first, as I said, not two fractions, make it 1. So what I do to make it 1 is I make the denominators the same. So I'm ending up with sin square x minus sin square x cos square x. And remember, it's an expression, it's not an equation. Keep the denominator. Okay. And now I can take out a common factor. And what is the common factor? It's sin square x. And it's 1 minus cos square x over cos square x. And I'm going to take you now to the formula sheet. I'll come back. Okay, so let's just go to the formula sheet. And remember, it's at the back of your question paper. So let's see if it was here. I'm just checking. I don't know on which one it was. Okay, let's just go back. Unfortunately, that was not. Okay, so on the formula sheet, can I just show you, it's the second page of the formula sheet. Can you see there, it would have helped you, that one. Okay, so just make sure that you don't say cos over sin or something like that, because that's for the cot. Okay, now on the formula sheet, they will show you the basic one. Now this is the basic one. Okay, so it's cos squared theta plus sin squared theta is 1. But you can play around with this one. So if you play around with this one, you can say, okay, but can I find 1 minus? So if I take this cos squared, so I can say that sin squared theta is equal, and I can put the x, doesn't matter, 1 minus cos squared theta. And it's very nice that they give you a formula sheet. In the old higher level, you just should have learned everything. But now there's so much more formulas, so they help you a little bit. So don't forget, I'm going to show you that this one. So they give you the original, but manipulate that original one. Okay, let's go back. Let's go back to our question. Okay. I think it's here. Okay, now make it a bit bigger. And can you remember now what I showed you on the formula sheet? So now I'm going to say sin squared x. And remember, that's also sin squared x. Okay, in x, not in theta. So please don't go to theta. Okay, this is the angle in this case is x. So this is going to be sin to the power. Okay. Let's not do that one. Now, from here, I must start to look up. I look at this side there. Do you see? And I say, oh, do you see what I see? I can go back to my tan. So I can say this can become what again? Tan squared x and then sin squared x. And if I look up now, I say, oh, that's excellent. Now the left-hand side is equal. So therefore, left-hand side equals the right-hand side. Okay, and that's how I do it. Okay, and again, I think they will give you marks if you at least were making it one term. If you at least came to that step, okay? And then if you take out the common factor and then just ending up with the conclusion, coming to that right-hand side there. And that's how you do question number 5.